Okay, I'm back here again. I just wanted to explain this because I do find this to be a little bit wordy, this paragraph right here. So, because it's talking about how do you know if two triangles are similar? The first situation, which matches the first sentence there, if you find that you have that case of two equal angles. So for example, if you know, let's say you look at two triangles, and let's just say you figure out, okay, I'm going to use this example right here. We know that angle B is equal to angle M. Angle B is equal to angle M. We also know that angle C is equal to angle N. Well, we have two matches on angles now, guys. We have two matches. This one matches this, and this one matches this. Therefore, we know that we have similar triangles. Okay? So if you can find that match, you know for sure that you have similar triangles. Case 2, which is the second sentence there, and I'll try to make this a little more easy for you. Case 2 is when, it says, you have to read really carefully, you have one pair of corresponding angles and corresponding sides. So what that means here is, let's say if you had two triangles, let's say this angle matched that angle, so you know that angle B is equal to angle M, so we've fulfilled that requirement. So it says one pair of corresponding angles and corresponding sides. So what you'd have to figure out here then is, okay, are these sides corresponding? Are they kind of equal reduction or enlargement? So if you have, let's say, side CB is congruent or equal here to side MN, that's your second case. So you would have similar triangles, okay? So again, those are your two cases. Now, again, you might be thinking, it's not quite clear yet, but I'm gonna go through an example here or two, and hopefully this will become more clear. So let's now actually look at this example for what it's worth, and actually figure some things out. Okay. Example 1, given the two triangles below, find the length of n. Your first step is you have to confirm that the triangles are similar. So are they similar? And we have two cases right now. Case 1 was, remember, when you have two sets of matching angles. Okay. The other case, case 2, which we just did, is when you have matching angles and you have the congruent or proportional sides. I'll just go matching sides. So you have to set up, be able to establish if the triangles are similar, either using case 1 or case 2. So let's look at this here then. Let's erase this. What do we know about these two shapes? Well, I see that little x in that angle and a little x in that angle. Therefore, I know that angle B is equal to angle M. And they put this kind of half angle shape here and this one here. So I know that angle C is equal to angle N. Well, everyone, I have now proven that these two triangles are similar because they have two matching angles. That is a case 1 match. So we have now said that we know that these two triangles are similar. We've done this part of the question. And then use a proportion to solve for n. Well, what the heck does that mean? We've done this already. This is where you're going to use kind of the cross multiply and divide, what you know and what you want method. So, do we have matching sides per se? You see, what I mean by that is we know the length of BC and we know the length of MN. So this is going to be the side that I know, or the match that I know. So B to C is 5 inches. Matching on the next triangle, it is now worth 2 inches. So it certainly has undergone a reduction. Now we go to the side that we want. You see, it says that we want side N. So that's going to be matched from here to here. So it's going to be 7 inches on top, and it's going to be the n on the bottom. You're going to now do the cross multiply and divide method. Find your your diagonal with the two values that are numbers. So 2 times 7 is 14. Divide by 5. That means your n value should be 2.8 inches long. And that is going to be what you have right here for an answer. Okay, since I find this one to be kind of a little bit tricky, let's go on to another one. Example 2. Okay, it says here, Kevin notices that a 2-meter pole casts a shadow of 5 meters long, and a second pole casts a shadow of 9.4 meters. How tall is the second pole? So what you do here first is you always make a diagram, everyone, because in this case, these would not have been given to you. They gave you the information and they want you to draw it. So if you look here, here is your vertical 2-meter pole, and the shadow, of course, that goes along the ground is 5 meters, okay? And then the second diagram is now the pole. We're not quite sure how tall it is, but we know we have a shadow of 9.4 meters. Okay. So solution. First, always make a diagram if one is not provided. We just talked about that. Then confirm that the triangles are similar, and then use a proportion to solve for x. So let's do our test. Is this a case 1 or is this a case 2? Well, let's double check. Now you see they've put this symbol here and this symbol here. So if I were to call this angle A and let's call this one angle B, we know that angle A is equal to angle B. And then they put in this kind of angle symbol here again, or angle shape. We'll call that C and D. I'm just making that up. Angle C is equal to angle D. Well, right away, everyone, we now know that we have similar triangles because we have 2 sets of matching angles. So these are similar triangles. Once that is set up, we can now use a proportion to find for our missing side length. So what we do, I'll do it down here. So remember, this is what you know. This is what you want. Okay, so do we have matching sides? I look here, I have this shadow length and this shadow length. So 5 meters over 9.4 meters. Then we have to look at the vertical heights. So it's going to be 2 meters over x. And I explained in previous videos as to why we set it up in this fashion. Now we're going to use cross multiply and divide. Find the diagonal with both numbers. So it's going to be 9.4 times 2. Hit enter or equal, that's 18.8. And divide by the value you haven't used yet. So we divide by 5. That gives you an x value of 3.76 meters. So to solve this question, what did we have to do? Number 1, we had to draw it. Number 2, we had to prove if it was a similar case of triangles. And it was a case 1 because we had 2 sets of equal angles. Once that was done, we set up a proportion and solved it using cross multiply and divide to find a missing value. I hope you're finding this to be a repetitive process, and we'll give you some practice now to try to really master this and ensure that you're correct moving forward.